Alright, so let's take a look at this question. If f of x is equal to x squared plus 7x, find f prime of 3 using Archimedes' quotient. Just to recap, Archimedes' quotient, f prime of a is equal to limit as x approaches a, f of x minus f of a over x minus a. This is basically used to find the slope of the tangent, or the instantaneous rate of change, at a single point where x is equal to a. Okay, in this case, a here is equal to 3. We're finding the instantaneous rate of change when x is equal to 3. So if we're doing that, if I apply this into the equation, f prime of 3, which also just kind of translates to what is the instantaneous rate of change at x equals 3 of the function, is equal to limit. So wherever I see a, I'm going to plug in 3. So x approaches 3, f of x minus f of 3, x minus 3. Okay? And you can notice that there is an issue with this limit. We can see that as x approaches 3, the expression here is actually going to become undefined because the denominator becomes 0. So we need a way to cancel out this x minus 3. Now, you're basically going to get a way to do that when you simplify the numerator. So let's simplify the numerator. So f of x here is equal to x squared plus 7x. f of 3, if I wanted to solve for it, is 3 squared plus 7 times 3, which is basically 30. Okay, so if I rewrite this expression, now what it's going to look like, limit as x approaches 3, f of x is x squared plus 7x minus f of 3 is negative 30, and this is over x minus 3. Now we can see that the numerator looks like a quadratic. If we want to cancel out the factor on the denominator, what I want to do now is basically factor out the numerator. So you can look at x squared plus 7x minus 30. I'm going to factor this out. It's like factoring a quadratic in the form of ax squared plus bx plus c. So you can notice here that a is 1, b is 7, c is negative 30, ac here is negative 30. Recall your quadratic rules. You want to find two numbers that add up to 7, then multiply, excuse me, then multiply to negative 30. So two numbers that can work for this case is 10 and negative 3. And then what you want to do is you want to replace your middle term, 7x, is equal to a sum of these two coefficients. So 10x minus 3x. And then I'm going to replug this back in to my expression and factor out the first two and last two terms. So you get x times x plus 10 minus 3x plus 10. And once you know that the two factors on the inside are the same, you can factor by grouping, and you get x minus 3 times x plus 10. Okay, so now what you want to do here is I'm going to replace this quadratic in standard form, which looks like ax squared plus bx plus c, in its factored form. So you have, let's make some space for the limit, x minus 3 times x plus 10 over x minus 3, and then you have the limit as x approaches 3. And at this point, what you can see here is that the two factors on the numerator and denominator cancel out, and this gets rid of the restriction. So now we can actually let x approach 3. So if we let x approach 3, then f prime of 3 here is equal to 3 plus 10, which is 13, right? So now we basically calculated the slope of the tangent at x is equal to 3.